So this question is related to electricity. A student set up the circuit as shown. Three identical lamps are there and a switch A, B, and C, the lamps. Each lamp is marked as 1.5 and two cells are there, 1.5 volt cells with a negligible internal resistance. The two lamps label A and B. Light with a normal brightness when switch is open. Explain what will happen if the brightness of each what will happen to brightness of each lamp when the switch is. The two lamps A and B light with a normal brightness when the switch is open. Like when this switch is open, they have the normal brightness. But now they're saying what will happen if we close this switch, like if we connect here. Looks, each lamp is marked 1.5. So each lamp required 1.5 and two cells. So this is 1.5, this is 1.5. So combined EMF will be 3. Because they are connected in series, that's why the voltage will divide equally. But then, because they are identical lamps. But then what will happen if we close this switch? Now these two are in parallel and the combined resistance of A and C, because when they are parallel, the combined resistance will decrease. So this part will have a low resistance and this part will have a high resistance. And a region where we have a high resistance will have more voltage, and a region where we have low resistance, the voltage will be less. So what we will observe when the switch is closed. So when initially the switch is open, the brightness of the two lamps have the same brightness because they have the same resistance, receive the same voltage. But when the switch is closed, the combined resistance in parallel decreases. So less resistance means less voltage across A and C. So less voltage across A and C, it means the brightness of A will decrease. And what happened to brightness of B? That will increase. The next part is sketch a current and potential graph for a filament. Remember, for a filament bulb, as the current increases, the temperature also increases. As a result, temperature increases, the resistance will also increase because it's a metal. And if we have a current and voltage graph, on the slope of the current and voltage graph is reciprocal of the resistance. Means if the resistance increase, the slope will decrease. So what will the shape of the graph? Like this. And same thing, this is a current and voltage graph, negative axis, so it will be in this manner. So this is a current voltage graph. Explain the shape of this graph in terms of electron movement through the lattice. So why the resistance increase, slope is decreasing, so why the resistance is increasing? So because what happened when the temperature increases, as we are increasing a current, so the temperature increases, as I mentioned. So increase in temperature is due to the increase in the current. More current, as we are increasing a voltage and current, so more heating effect. So as a result, what will happen? The temperature increases. As a result, temperature increases, so lattice vibration will also increase. As a result, lattice vibration increase, so there will be more collisions between the electrons and the lattice. So electrons and lattice of a positive ion will collide often. So as a result, what will happen? Rate of increase in the current with respect to potential difference decreases. So rate of increase in current with respect to potential difference decreases, or we can say the slope will decrease.